All right, we're on the back side of day 2 notes for Unit 6, and it says, as shown in the diagram below, the diagonals of QRST intersect at E, and it says that QE is x squared plus 6x, and so right there, that square term already tells me this is going to be a factoring question. SE is x plus 14, and TE is 6x minus 1, and they want you to determine TE algebraically. So TE, if you look, has an x in it, so we need to solve for x. And based on the properties of the parallelogram that we talked about on the front side of our notes, we know that E is a midpoint of both diagonals. And since we don't have the length of ER or have an expression for ER, we won't be able to use that diagonal. But we do have the two parts on diagonal QS, and we know that these two pieces here are equal. We know that QE is congruent or has the same length as ES. And so we're going to take our x squared plus 6x, which is QE, and we're going to put it equal to x plus 14, which is what ES is being represented by. Okay. All right, because we have a square term, we're going to have to factor. We're going to get two answers, but we can't factor unless we're equal to 0. And we always want to keep our square term positive. And so we're going to go ahead and subtract x on over. Then we're going to go ahead and take 14, and we're going to subtract it on over. When we're finished, we're going to have x squared. Right here we have 6x minus x, which is positive 5x, and then the minus 14, and then equals 0. And now we're in good shape to factor our trinomial. In the top, we're going to go ahead and have our multiply be the last number, or the C value, which is negative 14, and our add be the middle number, which is positive 5, or our B value. Okay. There's only two sets of numbers that multiply to 14, 1 and 14, and 2 and 7. And I'm pretty sure it's the 7 and the 2, or the 2 and the 7, that will give us the 5 if we make the 2 negative. Those two numbers, when added together, will give you 5. When they're multiplied, they give you negative 14. And so we have our numbers for our factors. One of our factors will be x plus 7. Our other factor will be x minus 2. If we take our x plus 7 and we set it equal to 0, we're going to end up with x equaling negative 7. If we go ahead and take our x minus 2 and set that equal to 0 and add 2, we'll end up with x equals 2. And a lot of times in math, we can have two answers, except in geometry, when our problem here comes with a picture of segments or angles that can't be negative or 0. Usually it's the negative one that goes away, but we never assume. We always have to go ahead and plug in. So because they wanted us to find the length of TE, if we do 6 times our answer of negative 7 minus 1, that's going to give us negative 42 minus 1, which is negative 43. Well, that segment can't have a length of negative 43. So we're going to go ahead and now have a reason to reject our answer, and we'll keep the 2. And so now we'll plug in our real answer of 2. 6 times 2 minus 1 is 12 minus 1. And now we can say that TE is equal to 11. Okay? And so not only is TE equal to a length of 11, but ER would also have a length of 11. Okay, because they are equal. All right, number 6. In the accompanied diagram, PQRS is a trapezoid, so not a parallelogram. It says that PQ is parallel to SR, and they want us to find the measure of angle 1 and angle 2. All right, so if we look at them, hopefully you guys remember that the parallel lines are a huge clue, that if we trace over them, we can see who could act as our transversal, which I'm going to take it as this. And you can see that 20 degrees right here is between the parallel line and the transversal. And on the other side, so is angle 1. In fact, those two angles are called alternate interior angles, And when the lines are parallel, alternate interior angles are equal. And so this is also 20 degrees. And so angle 1 equals 20 degrees. One of our answers is done. Angle 2 is even going to be easier than that, since you can see that triangle here has two angles in it already. And so if we take 180 degrees in that green triangle, take away the 110, take away the 20, angle 2 is going to equal 50 degrees. And now we have both of our answers. All right, number 7. Which of the following statements must be true for a trapezoid ABCD? So a trapezoid is the first shape they're talking about. Oh, hang on, with bases AD and BC. So if the base is AD, we could go A here, D here, B here, and C here. Does that make sure? AD is a base because it's parallel to BC, who's a base. A, B, C, D. All right, so our picture's okay. Which of the following statements must be true for trapezoid ABCD with bases AD and BC? Check all that apply. All right, so in the first one, angle A is here and angle B is here. And they're saying that those two angles will add up to equal 180 degrees. And I'm going to have to go ahead and say that that is true. And so we're going to check this one, or we can circle it, one or the other. And we'll do both. All right. Those are those two angles that are between the parallel lines. They're the same side interior angles. Number 2, it says that the legs AB and CD are congruent. Let me just check, but I don't think they said that this was an isosceles trapezoid, just a trapezoid. And so we're going to go ahead and say that this is false. Okay? Only if it was an isosceles trapezoid. But they didn't say isosceles. Okay? Number 3, the bases AD and BC are parallel, and that is true. Okay? It's one of the main properties that a trapezoid has, is that those two bases are parallel. Check that. Number 4, opposite angles are supplementary. No, not in a trapezoid. This is going to be false. It would happen in an isosceles trapezoid, but not in a regular trapezoid. All right, so number 2 and number 4 were for isosceles trapezoids. They were trying to trick us. Okay. Number 8, it says in the accompanied diagram, ABCD is an isosceles trapezoid with AB being parallel to CD. And it also tells us that AD is congruent to BC, and they already tick marked them for us, so that's nice. This is kind of similar to that question number 6. So again, I'm going to trace over my parallel sides, trace over my transversal, and right there, the same thing happened in the last one. We have an angle here between the parallel line and the transversal of 30, and so we're going to have that same situation down here with angle 1. It's also between the parallel line and the transversal. Those are alternate interior angles. And so angle 1 is going to become 30 degrees. And then one of our answers is finished. Okay. Now we have to find angle 2, angle C, and angle ADB. So you know what? I'm going to do angle ADB next, because angle ADB is right here. It's the third angle in this green triangle. So I'm going to go ahead and take 180 degrees, take away the 70, take away the 30, and I'm going to have 80 degrees left for angle ADB. Okay. All right, so another thing we have to remember about the isosceles trapezoid, since that's what they called this one, is that the base angles are congruent, just like they are in an isosceles triangle. And so this angle down here of 70 has to be the same measurement as this base angle down here that's made up of angle 1 and angle 2. So this whole angle is 70. And if part of it's already 30, then the other part has to be 40 degrees, and that's angle 2. All right, so we can go ahead and put 40 degrees in here so that the base angles are both 70. And we have one last angle to find, and we have to remember that there's two sets of base angles. Two sets of base angles being congruent. So up here at the top is our second base set of base angles. And if we look here, this entire base angle, 80 plus 30, is 110 degrees. And therefore, this must also be 110 degrees. So angle C equals 110 degrees. We could have got that 110 bunch of different ways. We could have looked at this triangle here. We already knew the 30 and the 40, so there's 110 left. We could have looked at the angles that are between the parallel lines and making them supplementary. Yeah, but either way, however you get to the answer. All right, last question, number 9. In the accompany diagram, isosceles, there it is again, isosceles trapezoid, ABCD. It has AB being parallel to CD, diagonals DB and AC intersect at E. Which statement is not true? Okay, so let's take a look at our choices. In number 1, we have triangle CBA. Triangle C to B to A is that triangle. And they're saying it's congruent to triangle DAB. D to A to B. Would those two triangles be congruent? And I think the answer is yes. If we go ahead and pull these triangles out, we have 5 theorems that prove triangles congruent. All 5 theorems require 3 pieces. So I'm wondering if I can look here and say, all right, since this is an isosceles trapezoid, I know that this side would be equal to that side, since the legs or the non-base sides are equal. I also know that the diagonals in an isosceles trapezoid are equal. Okay. And I also know that the base angles in an isosceles trapezoid are equal. All right. And I also know that this bottom side AB is a shared side. It's the same side in both triangles. Okay? And so if we look at our markings, we have a couple theorems. We have side angle side, we have side side side. And so these triangles would be congruent. So this would be true, except we're looking for which one's not true. All right, I'm going to erase and we're going to try again with a different set of triangles. This time, they want triangle ADC. ADC. And they want to see if it's congruent to triangle ABC. ABC. Well, just looking at it, they don't look very equal at all. We could pull those triangles out. And mark them and see if we can mark them. We know that this side here is equal to this side here because those are the legs. We know that this side here is equal to that side because that's a shared side, AC. But you know what? This top base is smaller than that bottom base. And so even though it has 2 sides equal, I don't think it has a third side equal. In fact, I don't think the third side could be equal. And therefore, those triangles cannot be identical twins if they're not exactly the same. And so I'm going to go ahead and pick choice 2 as my statement that I don't think is true, but I'm going to look at my other ones. In number 3, it talks about angle CDB. C to D to B is this angle here. And they want to see if it's congruent to angle DBA. DBA is this one here. And we've talked about those in the last couple problems, but those are alternate interior angles. Since these are parallel, that's your transversal. There's that Z shape. This is true. All right, and then the last one says AC, which is one of my diagonals, congruent to BD, which is my other diagonal. And we know in an isosceles trapezoid, that is a property. The diagonals are congruent. In fact, that's one of the main properties that makes the trapezoid turn into an isosceles trapezoid is congruent diagonals. And so I'm going to stick with my choice 2. All right, guys. So that's some properties on your parallelogram and a little review of trapezoids from day 1. And so hopefully you're remembering the properties. I know that they're tricky. Try to make sense of them. All right, I'll see you guys on the next day of notes.